Okay, we're going to start this unit off by talking about just a kind of a big umbrella term, and then we'll break it down further as the unit goes on. That big umbrella term is a relation. Okay, so we're going to talk about what a relation is. Relation, the first thing that might come to mind is a relationship. Relationship is something between two people. A relation, mathematically, is any comparison of two quantities. Any comparison of two quantities. Spell that right. All right, well, what are two quantities that we always see in math? Okay, specifically when we graph them. A relation can also be defined as any set of ordered pairs. Okay, so those two quantities we normally see are x and y. Okay, so any set of ordered pairs. All right, so again, that's a very broad definition. Okay, a relation is any set of ordered pairs. Okay, that's covers a lot of things in math. Almost everything in math can be considered a relation. Okay, there's a couple ways that we express relations. Okay, kind of meaning we visually see it. The first way is kind of what we already defined. You can list a relation as ordered pairs. The second way we could express a relation is through a table. In ordered pairs, you got x, y pairs, x comma y. A table, either can be vertical or it could be horizontal with x's in one column, y's in the other column. Relations can also be expressed graphically, so through a graph. Now, all three of those you're probably familiar with. This fourth one you might not be familiar with. It's called a mapping diagram. Mapping diagrams are also sometimes called arrow diagrams. All right, and the last way, and I'm not going to put it as number 5. I'm going to put it as a star, because it doesn't apply to every single relation, but it does apply to some of them, and that's an equation. So not all relations can be expressed as an equation. Some can, some can't. Okay, so we'll put that as a star. We're just going to deal with the first 4 for now. Ordered pairs, tables, graphs, and mapping diagrams. Before we get into that, we got to talk about the coordinate system. Okay, the coordinate system is a graph. Okay, you've seen them for years at this point. Coordinate system is 2 intersecting number lines. Okay. So in elementary or middle school, you probably did a lot with number lines. Number lines are just one-dimensional, but when they intersect in a coordinate system, it becomes 2-dimensional. For the 2 number lines, they're not just 2 random lines. One's going to be horizontal and one's going to be vertical. All right, so these are our 2 intersecting number lines that form this grid pattern. We're going to just label the key points of this. I know you're probably already familiar with all this. Let's start in the middle. Okay, where do the 2 intersecting number lines intersect? Okay. Right in the middle. That is your point of origin. Point of origin. Sometimes it's listed as P, O, 0, comma 0. 0, 0 is the point of origin. Okay. All right, well, you notice that we do get this grid pattern, right? So the 2 intersecting number lines break off into 4 separate groups, 4 separate regions. Those are called quadrants. Okay, so let's list that out. So 2 intersecting number lines, horizontal and vertical. And it's broken up into 4 quadrants. The first quadrant, and we usually label them with Roman numerals. The first quadrant is the top right quadrant. Okay. And then from the top right, it goes counterclockwise. So top left is quadrant 2. bottom left is quadrant 3. And then bottom right is quadrant 4. Okay, so 4 quadrants. Okay, let's go back to talking about the two number lines. The horizontal number line is the x-axis. So the x-axis is that bold line. Okay. Any point on that line is on the x-axis, and any point on that axis has the ordered pair, whatever the x value is, and then comma 0 because there's no vertical movement. And then the y-axis. The y-axis is vertical. This is the y-axis. Okay. And any point on that axis is 0, comma y. So what are these, x, comma 0, 0, comma y? Those are called ordered pairs. Again, you should be familiar with that at this point. Ordered pairs are just points on the graph. Okay. And those are the x, comma y's. Okay, it's kind of like the address of a point. So it's an XY address. Okay, just like your house has an address, each point on the graph has an address. Okay, the address of the point of origin is 0, 0. The address of something on the y-axis is 0, comma y, depending on where it is. Same with the x-axis, x, comma 0. Some things about the quadrants and their ordered pairs. Well, as you move right on the x-axis, you're going towards positive values. Okay, numbers bigger than 0. As you move left on the x-axis, you're going towards negative values. Similarly, on the y-axis, up and down, up is positive y values and down is going to be negative y values. Okay? So if you look where each of these quadrants lie, well, quadrant 1 is right and up. So every ordered pair in quadrant 1 is going to be positive, positive. So the x value is going to be positive, the y value is going to be positive. In quadrant 2, it's left and up. Okay? Well, left is negative and up is positive. So the x-axis, or the x value, is always going to be negative in the second quadrant and positive in the third. And then really quickly for these, third quadrant, both are negative. It's down and left, left and down. And then quadrant 4, positive x value, negative y value. All right. Ordered pairs, aka just x, comma y, we already said. Any point on the graph. And it's the coordinate address. So Ken already mentioned all this. The x-coordinate of an ordered pair is the horizontal distance from the point of origin. The horizontal distance from the point of origin, 0, 0. And then the y-coordinate is your vertical distance from the point of origin. The vertical distance from the point of origin. Again, all that should be a review. Should be familiar with all of that except maybe the mapping diagram. These next two are very, very important for Algebra 1. Okay, domain and range. You might have done them in 8th grade, but it's very important for us this year. What the domain is all possible x values in a relation. All possible x values in a relation. And the range, you might be able to guess, is all possible y values. Now when I was younger, I used to always mix up domain and range. Which one's X, which one's Y? Okay. And the way I figured out how to, help me remember is that in alphabetical order, D comes before R, domain comes before range, and in alphabetical order, X comes before Y. So domain is X, range is Y. That's, at least it helps me. All right, now your X values and your Y values sometimes go by different names. Your X values, which are now also called your domain, they could also be called inputs or your independent variable. So X values, domain, input, independent variable, they all kind of are interchangeable now. All right, and the opposite for the Y values, for the ranges. Ranges are sometimes called outputs or dependent variables. All right, how do we write domain and range? Well, there's two common ways that you'll see it. You'll either see just all the numbers listed out inside of curly brackets, or you'll see it written as an inequality. So let's go back to talking about relation representations, or how do we express relations. Well, you have to be given one of the four to create the other three. So in this problem, we're given the ordered pairs. Our relation has three ordered pairs: 1, 2, -2, 4, and 0, -3. Okay. I'm going to list it out in the other three representations, so a table, a graph, and a mapping diagram. Starting with the table. Okay, again, tables are very similar to ordered pairs. In the table, I'm going to do this one vertically. I'm just going to have an X column, vertical line, and then a Y column. And all you do to create the table is take the ordered pairs and list them out in the same order. Okay. Now, the only mistake people really make with tables is sometimes students will put the X values in like increasing order and the Y values in increasing order. You can't do that. The X value has to stay with the Y value. So whatever's in the ordered pair has to stick together. So we have 1, 2, -2, 4, and then 0, -3. So easy stuff. The graph should also be fairly easy. We know that a graph is two intersecting number lines. You got your y-axis and your x-axis, and each of those ordered pairs corresponds to a point. So let's make some marks here. Each hash mark is going to represent one unit, one value from the point of origin, and then just put a dot at each of those ordered pairs. 1, 2 means over from the point of origin 1, up 2. Okay, always X and then Y, over and then up. -2, 4. -2 is going left because the X value is negative, and then up 4. Okay, need one more hash mark there. Okay. All right, and the last one, 0, -3. So that's on the y-axis. It means from the point of origin, you're moving 0 spaces left or right. So it's going to be on the y-axis. Okay. So 0 down 3. So that's my graphic representation. Now the new one is the mapping diagram. The mapping diagram is going to have two ovals or two rectangles. Usually we see them as ovals. So we'll do an oval. Whoops. All right, so there's one oval. Clone that. We got our second oval. So this is going to be the mapping diagram. Now, in the table, the ordered pairs have to stay together. In the graph, obviously, the ordered pairs have to stay together. In the mapping diagrams, usually what we do is we put them in increasing or decreasing order. Okay. Now your mapping diagrams can be labeled several different ways. A lot of times you'll just see them X and Y. Okay. So you can see X on the left, Y on the right. Okay. You might also see them labeled as input and output, or domain and range. Okay, remember, these are all interchangeable words now. Okay, so you do it as however you want. I'm going to do X and Y for these. Okay. So in your X oval needs to be all the X values. I'm going to put in them in order. So all my X values are -2, 0, and 1. And then put all your Y values in. All your Y values are, again, I'm putting them in increasing order. It's -3, 2, and 4. Okay. So the mapping part of this, again, this why it's called a mapping diagram or also an arrow diagram, is that now we're going to draw arrows from the X value to its corresponding Y value. Okay. So the ordered pair in the first one was 1, 2. So that means from the X value 1, you're going to have an arrow pointing towards 2. The second ordered pair, -2, 4. So from -2, arrow pointing to 4. And then 0, -3. From 0 pointing towards -3. So that's a mapping or an arrow diagram. So these are my 4 representations. All 4 of these, the ordered pair, the table, the graph, and the mapping diagram, all represent the same relation. Okay. Just written in 4 different ways. Alright, so let's talk about our domain and range. How do we write domain and range? Our domain, remember, are all the possible X values. So what we do is you could write out the word domain. I usually just do a capital D, then a colon. And then for these, we're going to use a curly bracket and just list out all the domain values. Remember, domain values are X values, so list out all the X values that we have. Again, same with the mapping diagram, usually we put them in order. So our domain values are all the X values. You got -2, you got 1, and you got 0. And again, I'll put those in order, -2, 0, and then 1. That's it. That's the domain. Those are the X values in this relation. The range, same thing. We'll do capital R, colon, curly brackets, and then just list out all the Y values. Okay, now again, you can get the Y values from the mapping diagram, you can get the Y values from the graph, you can get the Y values from the ordered pair or the table. And our Y values are -3, 2, and 4. So that's our domain and that's our range. One thing to note when you're listing out domain and range is you don't include repeats. Now ours didn't have any repeats, but if there are repeats, don't list them twice. I'm going to skip the practice for now and do that at the end. But the last thing we want to talk about is independent and dependent variables. So again, these mean the X values and the Y values, the inputs and the outputs, but they're more often used to describe scenarios. All right, your independent variable, which remember is your X values, your independent variable determines the result. And then your dependent variable is the result. I'll put this over here. So independent determines the result, dependent is the result. Okay. The dependent is dependent on the independent variable. So we have 2 scenarios here, and we're going to decide which one's independent and which one's dependent. First scenario states, as the amount of rain decreases, so does the water level. Okay. So in your mind, think about this a little bit. Is the amount of rain dependent on the water level, or is the water level dependent on the amount of rain? Okay. Does the water level cause the amount of rain, or does the rain cause the water level? And this makes sense. The amount of rain determines the water level. So the amount of rain is the independent variable. And the water level is the result, the dependent variable. Okay. The amount of rain determines the result, and that result is the water level. So look at the second one. The number of calories you burn increases as the number of minutes you walk increase. So does the number of calories determine how many minutes you walk, or does the number of minutes you walk determine the amount of calories you burn? Again, think about it a little bit. And you should come to the conclusion that the number of calories you burn is dependent, or it's determined by the number of minutes you walk. So the number of minutes you walk is the independent variable, and the number of calories you burn is the dependent variable. All right, and your homework, and we'll finish this up in class, your homework's going to be this practice problem. Express these 4 ordered pairs as a table, a graph, and a mapping diagram, and then state the domain and range.